Okay, we're asked to find the area of the shaded region. So before I solve the equation, let me analyze something. We need two concepts here. So first, if you are given two functions, a function fx and function gx, that's g of x, and we're asked to find the area. So area bounded by these two, that's formed by these two curves, is always integral from their point of intersection as the lower and the upper limits from a to b of fx minus gx dx. So the area is the definite integral of this from a to b. So if you notice, the upper function subtracts the lower function, so that's the first thing. Again, secondly, if we have this graph, this is a sine graph. So why this is a cosine graph? So if you have from here to here to be a, from here to here is also a. That's the magnitude. So why is cosine? So that's it. So there's what we call the period. The period is, if you notice for sine, this is sine graph, this is y equal to sine a sine kx. Why this is for cosine, y equal to a cos kx. So what is k? K is a positive number and is related to the period. Period is t. Period is always t. T equals 2 pi over k. So what is the period? The period is just the maximum from here. If you notice, this starts from 0 and ends here before starting again. So this is the period. So for cosine, it starts from here and ends here also. So this is the period. Period is the time taken to complete a revolution. So from here to here is t. So we need to get the period for each of the graphs. And how do you do it? We use 2 pi over k. So in this case, we are given the periods, so we need to get k. So from here, the function, we have two functions. From here is sine and cosine graph. So we need to get the exact graph. So as you can see, for the first graph here, which is cosine, it starts from here and ends here before starting again. So you see that the period for t equal to 2 pi over k. For cosine, the period is 2 pi, which is 2 pi over k. So from here, you see that k is 1. But for sine, if you notice, it starts from here, ends here before starting again. 2 pi over k. So from here, k is 2. So what do you have to say? The graph, the equation for the cosine graph is y equal to a. As you can see, a is 1. So 1 cos k is also 1. So 1x, which is x. Y for sine, we have y equal to the same 1. So you can see is 1. Sine k is 2. So 2x. So we have the two functions now. And for us to get the area, we have two areas here. So we need to get a1 and a2. You add it together. And we have three limits here. We have 1, we need to get this, and we need to get this. And how do you get these three? We need to equate the two functions. So at the point of intersection, so we need to get the point of that is the value, the x coordinate of the point of intersection. As you can see, it's 0 here. So we need to get this and this. And how do you do it? At the point of intersection, you see that the two function, you equate the two function, that is sine 2x equals cos x. And from our double angle identity, sine 2x is 2 sine x cos x, which is equal to cos x. So we move cos x to the left hand side. We have 2 sine x cos x minus cos x equal to 0. And we notice we can factor cos. So cos equals, cos times 2 sine, that's what is left inside is 2 sine for this, and 1 for that, that's minus 1. And for the product of two numbers to be 0, one of the numbers must be 0. So either cos x is 0 or 2 sine x minus 1 is 0. It's now arc cos of 0. Y x here, that is making x the subject, is now arc sine of half. The arc sine of 0 is either pi over 2, that is 90, or 3 pi over 2, which is 2/7. That's why we have here this pi over 2 is 3 pi over 2. Yes. So y here is 30 degrees, which is pi over 6, or 150. 150 is 5 pi over 6. So that's why here is pi over 6. And here is 5 pi over 6. But we don't need it. What we need is just pi over 6 and pi over 2. So therefore, the area we are looking for is the sum of this and this. So we need to get this and get this. We'll add it. So for A1, the upper function is cosine. Y for A2, the upper function is sine. So we now have that the area is now A1 plus A2. So for A1, we have that integral from 0 to pi over 6 of the upper function is cos. So we have cos x minus sine 2x dx plus y for A2, the upper function, that is the lower limit is now pi over 6 to pi over 2. Yes, as you can see. See it. This is pi, the lower, while the upper is pi over 2. While the upper function here is now sine. So we have sine 2x minus cos x dx. So we integrate. The integral of cos is sine. One integral of sine is minus cos, so plus cos 2x over 2. From 0 to pi over 6. We move to the second one. Why this is integral of sine is minus cos. So I have minus cos 2x over 2 minus integral of cos is sine, so minus sine from pi over 6 to pi over 2. So we substitute. This is sine pi over 6 plus cos. If you substitute here, we have pi over 3 over 2. That's the upper, substituting the upper limit minus, we substitute the lower limit, which is sine 0 plus cos 0 over 2. So we are done with this. So plus, for this, we substitute, this is minus cos, if you substitute this pi over 2 minus sine pi over 2 minus, substitute the lower, which is minus cos pi over 3 over 2 minus sine pi over 6. So we add, as you can see, this sine pi over 6 plus, you get this minus times minus plus, so we have 2 sine pi over 6. So we are done with pi over 6. So coming here, we have cos pi over 3 over 2. Is there any other one? Okay. Minus, okay, minus times minus plus. So we have plus 2 cos pi over 3 over 2. So we are done with that. We have minus sine 0 is 0 minus cos 0. Cos 0 is 1, so minus 1 over 2. While here we have minus cos pi is minus 1, so plus 1 over 2. So we have minus sine 90 is 1. So, okay. So we have 2, this gone, this, so this, they are gone. So we have 2 sine 30 is half plus this cos 60 is half, so we have half. You get, this is half. So the half, we are left with 1 over 2 minus 1. So the answer is half. So our answer is half because this is 1. 1 minus 1 gone, so we are left with half. So that's it. The answer is option B. That's our answer, option B.